Alright, in this video tutorial, we're going to practice the application of apply family functions in R, specifically apply, tapply, lapply, and sapply using several examples. The main benefit of apply family function is that we can get rid of for or while loops. They are also easier to the point and faster approaches with fewer line of codes compared to loops. And also, you don't need to install any package to execute apply family function as they are built-in R functions. So let's write a command that we're gonna practice apply family functions, and the first one is apply. But first of all, let's load the data. We're gonna work with the empty cars data. So if I type data and here empty cars, if you run this line of code, so we have this type of data for each type of car. We have mpg, horsepower, weight, and so on. Okay, so there are some attributes associated with each type of car. And if you look at the structure of the data, so check the structure of data, str of this empty car. So you can see that all of the data are numeric. So the data are, you can do calculation for all variables. So the main functions from apply family, the first one is apply. So first one, so let's begin with apply. So if you put the question mark and then apply, so the apply function has three main arguments. The first argument is your data frame or list or matrix. The second argument is margin, and margin defines how the function will be applied. Okay, so if the value of the margin is 1, it means that the function will be applied on the rows. If the function is 2, it will be applied to the columns. If you use, for example, C 1 and 2, it will be applied to both rows and columns. Okay, and fun is the function that you have, for example, minimum, maximum, mean, standard deviation, or it can be your own defined function. So let's say I want to find the average or mean of each column in this empty car. Okay, so I want to find what is the mean of each of these columns in this data set. So if I don't use the apply function, the classic way is that, for example, I have to find the mean for empty cars. I have to, for example, first select the first column, run this line of code, so it's 20. Then go to the, again from the empty cars, and select the second one, run it, and it's 6, and so on. So I have to repeat that 11 times, this process. Another approach is that I could use a for loop that loops through each column and computes the mean of each column, but it can also be, for some people, challenging and time consuming compared to the apply function. But if I use apply function, it will be apply, so the word apply, then your data set, your data frame, which was empty cars, right? So I'm gonna apply it to the column. So the margin is gonna be 2, and I'm gonna calculate the mean, right? MEAN. So the function is mean, and if I hit the run, so you can see it will calculate the mean for each column. Okay, so it is very powerful, simple, and straightforward compared to this approach or using for or while loops. Okay, so how about if I want to find the mean of each row? Okay, again, if I don't use apply function, you should use mean of each row probably 32 times, so it's not time efficient, right? Or you have to loop through each row and then calculate the mean for each row. But if I just change this, for example, so I have this for the columns. So if I change the margin from 2 to 1, it will calculate the mean for each row in this data set. Okay, so that's how we can use the apply function. And another thing is that it's not just mean of the data. You could, for example, calculate the standard deviation. Okay, doesn't really matter. Standard deviation. You could find the minimum value. You could find the, for example, maximum value. Or you can have a function that you define it, and you already defined it, and you can use it here as the third argument in the apply function. Sometimes in your data set there are some NA or missing values. Okay, so in this data set, empty cars, we don't have any missing value, but we can artificially create missing values just for the sake of understanding. So I'm gonna tell empty cars that this data set, empty cars, for the row number 3 and column number 4, it is a missing value. Okay, so if I run this line of code, and now if I look at the empty car, row number 3, column number 4 is a missing value. Okay, now if I use the apply function for the columns, okay, here, if I run this line of code, I will see that I got NA, or missing value, for horsepower, right? So and the reason is that it doesn't have any value, so how it could find the average for these values when there are missing value here? Okay, so that's why it returns NA. So to avoid this type of problem, we have to remove the missing values from our calculation. So how we can do that? So when I, for example, when I want to use the apply function here, okay, if I want to remove the missing values, so let me make some space. So if I want to remove the missing value, I add another argument, that NA dot RM, which means that remove the RM, equals to true. Okay, now we can see that for the horsepower, R is able to find the horsepower. Okay, so the average of the horsepower. Okay, so sometimes in your data set, it's very common that you have missing values. If you want to remove the missing values, another thing is that you have to add another argument, na.rm equals to true. Okay, so you set that remove the missing values to true from your calculations. Okay, and sometimes you have a data frame or data set that the values seem like number, but when you use apply function, you will get an error. Okay, that you are not able to apply the function. So for example, let's load the data of so here data of chicken weight, I think. So if you look at this data set, chicken weight, so you can see all of the variables here. Sorry, this one. So weight, so we have the weights for the chicken, time, check, and diet. So it seems like all of them are numbers. Okay, so you should be able to use the apply function without any problem. But here, if you look at the structure of the data, structure of the chicken weight, so you'll notice that the data for weight is numeric, time is numeric, but chicken is ordered factor and diet is factor. Okay, so it's not a number, it's categories. Okay, so here chicken is a type of chicken, here diet is a type of diet. It's not, one is not a number, it's not based on the measurements. Okay, it's just a type of diet. So now if I run the apply function, okay, apply function on the chicken weight, and I'm going to apply it for each column of the chicken weight data set. I want to find the mean. So what's going to happen? If I run this line of code, I will get an error that the argument is not numeric or logical. Okay, so however the chicken weight here was check, diet, time, weight, all of them seem like uh, they seem like a numeric, but they are, as we saw in the structure of the data, these two are factor. Okay, so there are two options. So if you believe that these are numbers, you can easily convert them to numbers using as.numeric. Okay, so if you use as.numeric and then again save it in the data, it will consider this as a number, and then you will not get an error when you use the apply function. But these are not actually, they are type of chicken, they are type of diet, so they are not number. Okay, so we have to exclude these two from our calculations. Okay, so from chicken weight, I'm gonna say that I'm not gonna apply this function for all columns, only to column 1 and 2. Okay, so I'm gonna say that for all rows, so the first one is all rows, but column 1 and 2, how can I type 1 and 2? I have to use the C command or concat these two columns. So now if I run this line of code, it's gonna give us weight and time, the average of the weight and time for the chicken weight. Okay, so sometimes you may have, let's say you have 100 columns, but a couple of them are, for example, are not numeric. Okay, 2 of them are not numeric. Let's say here we had like 100 columns instead of 4. How can I remove or exclude column number 3 and column number 4 from calculation? So here I have to type, so I want column number 3 or 4, but I want to exclude them from calculation. Okay, so here probably doesn't, it's very simple, probably it's not necessary, but imagine here we had 100 columns and we wanted to exclude column number 3 or 4, any other columns. And then if you run the apply, again, you will get the same results. So that's how we can use the apply function to a data frame to find a value, to find a function value for a column or rows. So the next type of function from apply family function is tapply, and we already have worked with tapply in the ANOVA lab. The tapply function applies a function on a vector which is broken down by a factor or categorical variable. Okay, so if you type tapply, so for the tapply function, you will have x as your vector, you will have an index, which is your grouping variable, as your categorical variable, and then you will have your function. Okay, so let's see an example to better understand how this works. So in this example, I would like to find the mean of weight of average of weight of chicken, but for each type of diet. Okay, so diet was a categorical or factor variable. Okay, so I'm not gonna just find a weight for all of the chicken. I want to separate them by diet, type of diet, or by type of chick here, because both of them are not numeric and they are categorical variable. So this one is going to be your grouping variable, and this one is going to be your vector. Okay, so if you don't use the tapply function, it's going to be, for example, I'm going to find the mean of chicken weight, but for the column weight, but I'm going to separate it by, for example, the type of diet. Okay, so chicken weight $sign diet is, for example, type of 1. Okay, and then if I run this line of code, it gives us the diet, the weight for the diet type 1, and then I have to repeat that for diet type 2, type 3, type 4. How about if you have like more than 10, 20 type of diets? So this can be very time consuming, right? So another approach is that I use just the tapply function. Okay, so tapply function, and then here I have to mention what is your vector. Your vector is chicken weight, right? It's your chicken weight, but I'm gonna find the weight. Okay, so the weight. What is your grouping variable? I'm gonna find it based on the type of diet. Okay, so it's gonna be based on type of diet, and then I'm gonna find the mean. Okay, or it can be median or other things. So for each type of diet, it calculates the weight of chicken for each type of diet, the average weight of chicken for each type of diet. So I could easily find the standard deviation. Doesn't matter. I could find the lengths. How many chicken are for each type of diet? Okay, 220, 120, 120, and 118. Okay, or I could find, for example, the median, and so on. Okay, so we already practiced that the t-apply is very applicable in the ANOVA, because when you have more than two groups and you want to compare their mean or median, so t-apply is a very useful function in apply family. So the next type of functions in the apply family is lapply, and lapply allows apply a function over a list or a vector and returns a list of the same lengths of inputs. Okay, so if you type lapply, and so here it shows you that lapply, it doesn't even need a margin. Okay, so you just need to have your list or vector, and then you will have a function, and then you're very simple. Okay, just passes this list or vector to this function and then calculates that for each element in the list. Okay, so let's say I have a list. Let me create a list. Okay, so I'm gonna create a list of I'm gonna create a list here. For example, it consists of a vector, for example, 1, 2, 3, 4, and also consists of a sequence from -4 to 0, but the steps are 0.1. And also I have another element in the list, which is a matrix. Okay, and the matrix is from 1 to 12, and number of rows are 3 and number of columns are 4. Another thing that I have, for example, let's say I have a data frame, the entire empty cars data frame, because it was number, so it can be used, for example, here as another element. So data.frame. So in the list you can have a sequence, you can have a vector, you can have a matrix, you can have a data frame, doesn't really matter. Data, so d equals to data.frame of empty cars. Okay, so now let's save this in, for example, object list 1. Okay, and then run this line of code. So I have a list here, so it has a vector, another sequence, so you can see the values. You can see it's a matrix, and then it's a data frame within a list. Okay, so now if I want to find the total or the sum of the values, okay, the sum of the values for each of these observations, for each of these items, I can easily use lapply. Okay, and what is your list? Is list 1, and the function that I want to find is sum. I want to find the total number, and if you run this line of code, so for the first one the sum is 10. Okay, because 1, 2, 3, 4, add them up, 10. From -4 to 0, with this increment, the sum is -82. Here is 78, but for the last one was NA. Why we got the NA? Because empty car, if you look at the empty car, probably we have an NA value, definitely. So here, as you can see, 3 or 4 is NA. So when I add all of the values with NA, so you will get NA. So I have to I had to load the data again. Okay, so if I, for example, here load the data empty cars from the origin, and then now if I look at the empty cars again, So here I don't have NA. Now if I again build this list and then I use the TL apply, I can see that the sum of the values for the entire empty cars is 13,900 and something. So that's how you can use the L apply. So L apply is a function over a list. It can also be used for a vector, but it returns the values, returns the output as a list, as you can see, and with the same length of the input. Okay, so we had the length was 4, so the output length was also 4. And we didn't even need to specify the margin. Okay, you can apply L apply to a vector of characters. Okay, so let's say I have for example, an object name is a vector of names. For example, Alex, Joe, and Katie. Okay, so I have this vector, right? And I want to find the number of characters for each one. Okay, so here is very simple, but sometimes it can be like to have the number of characters. Okay, so I can use the L apply, and then the first one is gonna be your list or vector, which is name here, and the function I'm gonna count the number of characters, n char, and then you will see that for each one I have, for example, here we have 4 character, Joe is 3 character, Katie is 5, has 5 character. Or if I, for example, wanna convert this to uppercase, okay, so gets the value and convert them all capital. Okay, so here I'm gonna use L apply, and then for name, and the function is to upper. Okay, to upper, and if you run this line of code, it converts this to all cap, or it can be to lower, and so on. So the last type of functions in apply family is S apply. Okay, so number 4 is S apply. We have other versions, but these are the most important ones. So S apply works like L apply. It's exactly like L apply, but it tries to simplify the output to the most elementary data structure that is possible. Okay, so in other words, S apply is a wrapper function for L apply. So here we had an L apply, for example, for list 1. When I use the L apply, I got the result as this one. But how about if I use S apply? So here, instead of L apply, I use S apply. What's gonna happen? So here is the result. A, B, C is exactly the same, but it simplifies the output to the most elementary data structure. How about S apply for the characters? For character was like this, right? Was 4, 3, 5. But how about if I use S apply here? Let's see the difference. Yeah, Alex, Joe, Katie. Okay, so here was like this, right? But how about if I use the S apply? Alex, Joe, Katie. Okay, so as you can see, it simplifies the output to the most basic data structure that is possible.